Sodium percarbonate Na2CO3X YH2O2 in acid H plus produce CO2. The volume of CO2 48 cm cube at RTP. At RTP, 1 mole of any gas occupies 24 dm cube. So we write the equation Na2CO3 times X Y H2O2 plus H plus to release CO2. The volume of CO2 48 cm cube. We convert into dm cube divided by 1000. Then the volume is 0.048 dm cube. So the mole of CO2 is 0.048 divided by 24. For the sodium percarbonate, this is the volume, this is the concentration. Then we find out N is molar times volume. Molarity 0.1 times volume 0.01 dm cube. 0.001. Then we have 0.01 mole of sodium percarbonate produce 0.02. This carbonate ratio is twice, so the coefficient is 1 to 2. 2C, here 1C times X, so X is 2. Then the same identical sample 0.001 mole of sodium percarbonate or Na2CO3 times X Y H2O2 react with KMnO4. KMnO4 react with H2O2. KMnO4 is an oxidizing agent, react with H2O2 in this molecule in ratio 2 to 5. Then the concentration of KMnO4 is 0. So we find out the mole is molar times volume 0.05 times the volume is 24 or 0.024 dm cube. So the number of mole is 0.024. 1.2 times 10 to the power of minus 3 mole. This is the number of mole of H2O2. So this is 1.2 times 10 to the power of minus 3 present in 0.01 mole of all of this sodium percarbonate. So the ratio of 1 mole percarbonate to the YH2O2 is 1 to Y is 0.001 to 0.0012. Oh, sorry. This is the number of mole of KMnO4. We need to find out the number of H2O2. Firstly, we calculate by the ratio of coefficient 5/2 times 1.2 times 10 to the power of minus 3. That is 3 times 10 to the power of minus 3. So here, this is not this one, but 0.003. So Y is 3. So the ratio of Y to X is 3 to 2. For number 2, PbCl2 or PbCl4. So there are two types of Pb ion, either 2 plus or 4 plus. This is the composition. Number A, find out the empirical formula. From this, we assume that the mass of the substance is 100 grams. It's 100 grams. 100 grams of compound consists of 46.7 grams of Cl. And then we find out the number of mole of Cl divided by the AR, 35.5. Then we get 6 mole. For N, the AR is 1, so NH is the same as the percentage, 1.76 mole. For N, 6.14 divided by 14, the AR is 14, then we get 2. Sorry. 46.7 divided by 35.5, that is 1.3. 1.3 for this one. 6.14 divided by 14. This is 0.44 mole. For Pb, 45.4 divided by AR, 207. 45.4 divided by 207 is 0.22. This is the smallest. So all of this divided by 0.22. Then we get Cl is 6, H is 8, and then N is 2, Pb is 1. So the empirical formula is Cl6, H8, N2, Pb. If we count the MR, 6 times 35.5 the AR of Cl plus 8 times 1 plus N 2 times 14 plus Pb 207. We have the sum of AR. The sum of AR is 456 because the MR is 456. Then the molecular formula the same as empirical formula. Cl6, H8, and 2 Pb. Here the anion and the cation only one type each, so one anion, one cation, but the ratio is 1 to 2. We have this Cl as Cl minus, Pb could be 2 plus or Pb 4 plus, and then NH as NH4 plus, then NH4 plus, because the molecule has 2 N, then there are 2 NH4 plus. So the number of cation is NH4 times 2. So 2 cation. So the anion is 1 because this is the ratio. The anion is the rest of the atom. We have Pb and 6Cl as Cl minus. Cl minus 6. So the charge of Cl is minus 6. And then NH4 plus times 2 become plus 2. To be neutral, then the anion will be minus 2 in charge. The Cl minus 6, the Pb, we determine whether the plus 2 or plus 4. If we choose plus 2, then the total charge of the anion is plus 2 minus 6. That is minus 4. Not matched with what we need. So the Pb in this anion is plus 4 because with Pb plus 4 joined with 6Cl minus, then the total charge is minus 2. Plus 4 minus 6 minus 2. So that's the anion. So the formula is NH4 times 2 Pb Cl 6. This is an ion which is a complex ion. The charge is minus 2. Here the charge of NH4 is plus 1 times 2. The minus 2 of the anion, so this is the anion, this is the cation, comes from Pb plus 4 and 6Cl minus. Question number 3, N-chlorosuccinamide, this one.